fellow mathematician. Welcome to the study of numerical differentiation. In this video tutorial, we want to show how we can obtain the equation for calculating a second derivative numerically. So we consider Taylor's a series of equations of this function of f of x plus h, which can be approximated with the f of x plus f of first derivative of x h plus second derivative of x h squared 2 factorial plus then derivative of f of x h cubic divided by 3 factorial plus fourth derivative of f of x h power 4 4 factorial. Now when we change negative here, h with negative, so everywhere you have h there will be negative. There will be negative here squared, negative here cubic, and the negative here power 4. So when you introduce this negative, the function of f of x minus h will be f of x minus first derivative of f of x multiplied by h plus second derivative of f of x multiplied by h squared divided by 2 factorial minus 1 over 3 factorial and then derivative of f of x h power 3 plus fourth derivative of f of x h power 4. Here h is given by x minus x naught, whereby x naught is the value before x. So what we want to do, we want to add these equations. We shall add equation 1. We call that equation 1 and equation 2. So on the left hand side, when we add this equation, we shall obtain the following. So adding these two equations, on the left hand we shall have this. On the right hand side, we shall have f of x plus f of x, which will be 2f of x. So we shall have 2f of x. Then this first derivative, when we add, it will cancel to 0. Then the second derivative will be twice. So when we add the second derivative, we shall have twice second derivative over 2 factorial plus this third one, positive and negative will be 0. Then this other part here, we shall have. So we shall have 2f of fourth derivative of f of x h power 4 over 4 factorial. Now the last part can be, so we can write this one as equal to 2 f of x plus f of second derivative of f of x h power 2 divided by 1. 2 and the 2 will, when you have 2 factorial is like 2. So plus 2, so 4 plus 2 f of this power 4 of x h power 4 over 4 factorial. So we want to make a second derivative the subject of the formula. So when we do that, we shall have this one of x squared is equal to f of x plus h minus, we take this on the left hand side to f of x plus f of x minus h, then minus this other part here, which is 2 f of this x h power 4 divided by 4 factorial. Then we divide by h squared in both sides so that you obtain f of x second derivative is equal to. So we shall of half f of x plus h minus 2 f of x plus f of x minus h divided by h squared plus. So this one, the fourth derivative, we can make it, it is an error in approximating our derivative, our second derivative. So here, this can cancel. H power 4 divided by h squared, we can reduce it so that we have this error of under 2. So in approximating our function, our second derivative numerically, we encounter error of under h squared. That is that error. So thanks so much for your time. Today's objective was to show that the second derivative can be approximated numerically by this function here. And note that what we are considering here, we have our function here, this is our x, and the interval, they have equal interval from x to x naught. The interval is 8, x1, the interval is also 8, so equal interval of 8, 8. Here, 8 is given by 1, or x1 minus x naught. So that is our 8 in that function. So thanks so much for taking your time to study with me on numerical methods. And the objective of this video was to derive the formula for approximating the second derivative, which is used to solve an equation numerically. Bye bye. For those who are new, remember to subscribe to the channel so that you don't miss a single video which I upload for us every day. See you in the next presentation.